Hello, in this video we're going to create a thin plate, a solid model of a thin plate to run a simulation analysis. We're going to use Workbench to create the solid model, and the plate that we're going to do is shown here. The plate has a thickness of 1000 millimeters, and that's going to be set with the dimension H1 here, as you can see from here to here, and it has a height of 140 millimeters shown here, and it has a thickness into the page of 40 millimeters. This particular plate has a circle located here, shown here 300 millimeters, and it has a radius of 52 millimeters. Actually, in the example that we're going to do, we're going to actually set this at 200 millimeters, not 300 millimeters. Also, what we have is two dimensions here, V3, which is 70 millimeters. What this dimension is used is actually to position the rectangle. So if you think about it, we use a rectangle to represent the outer part of the plate. We set the width of the rectangle with this dimension H1, and we set the height of it with the dimension V2. And then to actually position the plate so that it's centered around the 0, 0, these are your coordinate systems, the X, Y, Z. We're going to center so it's in the middle. So that means that it's going to be 70 millimeters from this line up here, 70 millimeters down, and it's also going to be 500 millimeters from here to here. So essentially we use the V3 and the H4 dimensions to position the rectangle correctly around the center point. Likewise with this, when we do the circle, we use the R5 dimension to set the radius, and we use this dimension H7, which is 300 millimeters, to position the circle. When we come to do the notches, I'll just zoom up on this notch here, the two of them here. And what the notch is, it's an arc with a radius of 11.5 millimeters, and it's constructed by making a circle with a radius of 11.5 millimeters, but the notch penetrates 6 millimeters into the plate. So in that particular case then, the center of the circle is 11.5 millimeters in the bottom here, so that means that it's 6 millimeters up to this line here, and it's another 5.5 millimeters up to there. So when we draw these notches, we draw a circle, we size the arc using the R8 dimension, and the R11 dimension is the same notch down underneath here, and then we position it using the H9 dimension. It's a horizontal dimension to position it at this position here, and likewise we position it here using the H12 one. We position the bottom notch there, and we also set the position here, the radius of the circle using R11 at the bottom. The other thing we need to do is position the center of the circle 5.5 millimeters from the top of the plate. So we use that with this dimension here, V10, which is tricky to see here, it's easier to see down here. We use this dimension, V14, to position the circle in the correct position. So that's just an overview of what we're going to do. So if I come back out here. So in essence, what we use is we use dimensions to both size the shapes that make up the solid model, and we also use dimensions to position them. So if I come now and open up the window for Workbench, and I open up, we're going to do a static structural analysis. It takes a few seconds to open up. And here you see the series of steps that are needed to actually develop a model. We can give it a name here, so we call it plate. And we call it plate 5, because I already have a few done already, but you can call it plate 1. Now engineering data is already ticked. These are, as you run through these and do them correctly, you get a green tick here. If I click on engineering data, it automatically has structural steel as the default option. What we can also do is come here, and if I click on engineering data sources, it opens up this option. If I click on general materials, it will list a load of general materials here. So say we wanted aluminium, we can add that. Say we wanted concrete, we could add that. If I just minimize this by clicking that, you can see that these are now added, so we could use those in our analysis. I can close engineering data here. Now the next thing you need to do is come to units, and we switch our units to millimeters and newtons. And the other thing you need to do is tool options. If you're using this on VLab, it's essential that you switch the folder to your Z drive. So if I call that plate 5, For the temporary files, I'll put them in Z, plate 5, /temp. So I created 2 directories for where I'm going to store the files on my Z drive. So they're now created. So the next thing to do is come into the geometry. So if I click on that and open it, it says starting design modeler. It'll take a short while to do it. The design modeler took a while to do, but it worked. This is the design modeler, and this is what we use to create the solid model that you see here, basically. So if I click back into design modeler, if you look at your different planes, you have the XY plane shows up here, and you can see that you have your triad there, the 3 axes there. You have your different views. Now if I select here on this is rotate, I can actually come around and I can rotate that axis around. If I want to, I can click there, sorry, I can just rotate it like that. But if I want to get back to isometric, I click on that blue button there. That's back to isometric, and if I want to look straight down onto the XY plane, I can click on the Z, and now we're looking down on the XY plane. Next thing we need to do is come up here to our units, make sure we're on millimeters, and we need to sort out our scale. So if I click on the scale here, at the moment it says 80 millimeters. I'll just click off that. And now what I'm doing here is I'm rolling the mouse, the wheel on the mouse back towards myself, and that's expanding the scale out, and we need it up at about 500 or 600 millimeters. The next thing I need to do is we're on the XY plane. That's it there. I can do fit all here using that zoom to fit up here, or the F7 button, and then I can start to draw. So I come to sketching, and you have your draw option up here, modify dimensions. We come to draw, and we come to rectangle. And what I do is I just do an arbitrary rectangle here. Now it's kind of funny, it went back to 80 millimeters there. So what I'll do is I'll do an arbitrary rectangle, kind of centered around the 0, 0 point here. Then what I can do to actually set it is I come to dimensions, and I go to horizontal dimensions, and you see down here saying horizontal, select first point or 2D edge for horizontal dimension. That's our first 2D edge. Then I was looking for the second 2D edge, that's this one here. And then I can just hold the mouse down and drag it up. And this gives me H1, which is 218.78 millimeters. Remember, our plate is 1000 millimeters wide, so I just put in 1000 to size that. Now the next one I'll do is the vertical distance here. So this time it's select the first 2D edge, so I want to go find the distance from here. That's my first one, I'm looking for the second one. Down to there, bring it out here. That's V2, and I said that's 140 millimeters. Now you can see it's not fitted there, it's not centered correctly, but we can rectify that. If I show all, you can see it's off centered. It kind of did something funny on the scale there. So what we need now to do is to position it. Use dimensions to position it. So what we do is we come back to a horizontal dimension. And what I want is from here to here, I want that dimension to be 500. At the moment you can see it's off center, it's 107. So if I put in 500 there, and then I show all, you can see that it's now centered around the vertical axis, the y-axis. We also need to center around the x-axis, so we come now to our vertical dimension, and we'll basically say that we want from here down to here. I'll do it out on this side so it doesn't get cluttered. Phi4, and we say that that is equal to 70. And now you can see that our plate is centered around 0, 0. The next thing we need to do is our circle. So we say draw a circle, like so. Now I can just, it's about there, 200, and I can just size it like that. I don't worry about the size yet, because what I can do is, I know it's approximately in there. What I can then do is come and use the radius dimension to actually size it. So I bring it out like that, and or 5 here, I can come down and I can set it. I almost had it on 52, it's very close. It's now 52. To position it, I basically set the horizontal dimension from that point to 0, 0, that vertical line here, over to that point there. So what I can do here is a horizontal dimension from that line there over to that point there. I bring it up, it's H8, and we'll set that at, sorry, H6, we'll set that at 200. Okay, the next thing we need to do are the notches, which are a bit trickier. What you do with the notch, it's going to be over here at 300, so I come here and I draw circle, and I just pick a circle anywhere here. Okay, the first thing I'll do once again is come to the dimension, radius. Now it's important here, I'll show you why after, but when you put the radius on, put it down at a portion of the arc that's going to be part of the plate, that's going to be part of the notch. If you put it out here, it's going to cause you trouble. Yeah. So leave it there, and it's over 7, and it's 11.5 is the radius of this circle. And then what we need to do is set the horizontal dimension, so it's 300 millimeters from the center. So if I come to horizontal, so from the center over to that line there is H8, so it's 300 millimeters. So it's back over here. And then what we need to do is position it that it's 5.5 millimeters from the top of that plate. The center of the circle is 5.5 millimeters. Remember, it has to penetrate in 6 millimeters. So if you put the center of the circle at 5.5, the bottom of the arc will be at 6 millimeters from the top of the plate. So if I then come to vertical, I pick the center of the circle, I pick this, and I put it in like so, it's V9. And I say that's 5.5, and now it's put it in successfully. Now what I want to do is the box zoom, so if I come over here, box zoom is this magnifying glass with a cross in the center, and I can just zoom in like that. And next what we want to do is get rid of that part of the circle and the line from there to there. So what we do is we come to modify, trim, and we pick that section of the circle. So it trims from that point, that intersection to this intersection. And that wouldn't have worked properly if that dimension had been out here somewhere. I'll show that in a while. And then if you click on that section, it trims from here to here. So we now have successfully put our notch in place there. Okay, if I fit all again, we now have to do the same thing down here. So I draw a circle. Put it somewhere there. We dimension, and as I said before, make sure you put this dimension on a section of the circle that's going to form the notch somewhere down here. So it's over 10, 11.5, and then we want to position it horizontally. So horizontally from the center to this axis over here, and that is H11. So we'll set that at 300. And then we want a vertical. Now I can box zoom in here to make your life easier. We want a vertical from dimension from the center. No, sorry, vertical. From the center up to this line here. Doesn't want to work. Hang on. Vertical. From the center up to that line there. It's V12, and we're saying that that is, where's V12? 5.5 millimeters. So once again, we have our notch, our circle in the correct position. So to create the notch, then we come to modify, trim. We picked a section of the circle out here, so it gets rid of the circle from that intersection to this one. And then the line here, we click inside there, and it trims the line from that intersection to this one. So we now have this model created correctly, the only difference being we're 200 millimeters out with the circle. So if I fit all, the last thing we need to do is we need to create the 3D object. So what we do is we come back to modeling, I click here into modeling, I click XY plane sketch 1, so this is sketch 1. You can see when I select it, everything goes yellow. All the lines that make up that sketch go yellow. And if you look here, we have this extrude option here. So if I pick extrude, we don't really have to change anything along here. All I need to do is set the depth to 40 millimeters, and it adds material. So if I press OK, now what I have to do is come up here, right click here, and press generate. You can see there's a thunderbolt, sort of lightning, yellow lightning here. What that says is it's not going to happen until I press this generate. But now that I pressed it, you can see it's there. And if I look at the isometric view, you can see that we have a three-dimensional object with our notches in place. So if I zoom in here, you can see that the notches are there. They're extruded correctly. And if I fit all, come to here, there. I clicked in here and it puts a red dot in there. That becomes the center of rotation. It's very useful. And you can see that it's there correctly now. We have the notch in the bottom as well. And if I want to get rid of that center of rotation, I can just click anywhere outside there. Put it back to isometric by clicking the blue circle there, and we're back to isometric. So that's your solid model done. Make sure you save it. So I'll call this project Plate 5, and I'll call it Plate 5. You can obviously call it Plate 1 or whatever. It's just I've done a few different examples before. And it's working away saving the project. And then the next step, which is the second video, is where you open it up, the model here. And this is where you start setting the boundary conditions and so on. You're setting the forces and so on onto the solid model. Okay, thank you very much for listening. I'll just say no, I don't want to participate. I'll just show you, it's going to open up the model. It's taken a while. It comes down here, we're starting mechanical. But basically, you'll see this in the next video. So this is mechanical here, and this opens up the geometry that we've just created. It takes a bit of time to do it, but there's our geometry. And now we're in a position where we can put a mesh onto this, and we can set our boundary conditions. So the next video shows you how that's done. Okay, thank you very much for listening.